All right, so I was asked to take a look at two word problems that are early on in your book dealing with linear equations. And first one is going to be a distance problem. And the second one is actually going to be a mixture problem. So I hope both of these are going to help. When I drove from Miami to Orlando, a total of 240 miles. So I'm thinking something along the lines of Miami all the way to Orlando is 240 miles. Cool. All right. He drove 1 hour in city traffic and 3 hours on the highway. Oh boy. If the average speed of, so I have two different drivings basically that I'm doing. One is city and one is highway. So of this 240 miles, I have one distance that is city, and I have another distance that is highway. But the one thing I know is the distance of the city and the distance of the highway added together has to equal my total distance of 240. So the distance of my city plus the distance of my highway is going to equal my total distance, which I just said was 240. Now let's back up a little bit. I just drove back from vacation, and let's see, if I went 60 miles per hour and I actually drove for 8 hours, what did I get? Well, the hour labels cancel and I would get 480, and the label that's left is miles. And this is our formula for distance. Distance equals this guy, which is my rate, times this guy, which is my time. So whenever I'm doing distance problems, I'm working with rate times time. Okay. So, and I have the whole label thing going on. But there may be times where I want to find the rate. So the rate alone would start with dividing by t, as well as there might be times where I want to find the time, and I would divide the distance by rate. So I have other formulas that might come off of that, but distance equals rate times time is the big one. So for this first one, DC, I need a rate and a time. Well, my distance in city was, I have an hour, 1 hour, okay? Rate times time, so that's times 1 for 1 hour. And then my second one, I have a time of 3 hours. So this is 3 hours, and I know that has to equal 240. So this distance equals a rate times a time of 1. This distance equals a rate times 3. All right, so let's see, if the average speed on the highway is 20 miles an hour faster. So what if I said rate for the city, R, I'm going to call that rate for the city. So just R. So here's my rate for the city, which means I now need a rate for here, which is going to be 20 miles an hour faster. So in here, I'm going to put what the first rate was times this one. Rate times time, rate times time. Sorry, I ran out of room there a little bit. R times 1 is just R, plus, excuse me. 3 times R plus 20 is going to give me 3R plus 60. R and 3R is 4R. 4R equals, I'm going to subtract and get 180, which is going to leave me with R equals 45. So again, what was R? R was my city rate. R was my city rate. So I want to come back up here and double check my question. Okay, determine his average speed driving in the city. Found that, which is 45, and his speed driving on the highway, which was 65. So city, 45, highway, 65. Okay. But again, I needed a picture to get me started. I needed to remember my formula over here. And then I knew my two distances had to equal 240. And in order to find the distances, I needed the rate times the time, and went through and came up with what we need to do. The second problem, as I mentioned, was a mixture problem. And we never deal with acid solutions. To me, I'd like to tell you to take a 4-ounce beer that's a certain amount of alcohol and another one that's a certain amount of alcohol and mix them together and what do you have? But we're going to lay this one out and we'll do this problem. So I have how much of this first solution? So it looks like I have a 4% solution. It looks like I have a 12% solution, and I'm going to mix those together and create a mix that's 9% solution. So how do we go about doing this? Well, let me see what we can come up with. My first question says, how much 4%? So I'm going to say if I have an amount, I don't know how much 4%, so I'm going to call it X, will be mixed with 200 milliliters of a 12% solution. Well, if I put that together, what's the total going to be in my mixture? Well, if this is 50 and this is 200, I'd add those together to get 250 because I'm pouring both of these in. So I'm going to take that, I add these together, and that would be how much is in my mixture. So this amount, which I don't know, this amount, which I do know, it's going to give me this amount, which is here. All right, so this is a 4% mixture. This is a 12% mixture, and this is a 9% mixture. Okay, so this is their percentages. Now, if I took their amount and multiplied it by the percent, I'm going to get something like an individual total. So that I have 0.04 of X, I have 0.12 of 200, and those two, when I mix them together, are going to give me 0.09 of this 200 plus X. Okay, again, just like I added the amounts to get a total amount, I'm going to add the mixtures to get a total mixture. 0.04X plus 0.12 times 200 equals 0.09 times 200 plus X. 0.04X plus 24 equals 18 plus 0.09X. Subtract 18, that gives me a 6. Subtract 0.04X, that's going to give me a 0.05X. And that's really the same as 5 over 100. 6 equals 5 over 100. Multiplied by 100, I get 600 divided by 5. X equals 120. Kind of makes sense. 200 of this, 120 of this. There's more of this. Yeah, put it all together. So I hope that helps.